Technology brings us closer together, even when we're far apart. Google developer groups host Meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDG, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members alot, so I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Technology brings us closer together, even when we're far apart. Google developer groups host Meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDG, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members alot, so I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Technology brings us closer together, even when we're far apart. Google developer groups host Meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDG, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members alot, so I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Hello, everyone, and welcome to another GDG Athens online event. My name is Maggie Kodou. I'm one of the GDG Athens co-organizers, and today I have the pleasure to share this online stage with John to talk about the context, the manifest, and the Android system. Please feel free to make any questions and comments via the streaming platforms on Facebook, YouTube, and Twitch. So, hello, John. How are you? John, I think I can't hear you clearly.
Can you listen to me now?
Yes, of course.
I was on mute. Sorry about that.
Welcome,
Um,
John.
Thank you very much for hosting me here. It's my pleasure, and thank you very, very much for all this. I hope my talk will bring some benefit to people listening. I put some really great effort to do that, and I hope you will enjoy it.
Definitely, we will. So, John, are you ready for your presentation? Do you want to share your screen?
I can share my screen. I thought I'm sharing it
Great.
already. Yeah, I am. All
So,
right.
John, the floor is yours.
All right. Thank you very, very much again. So, hello everybody. My name is Ioannis Anifantakis. I am a software engineer for over 15 years. And today, what I wanted to present to you is an approach, a different approach to a subject about the context. We will see the context in an entirely different way from what we're used to by seeing it in from a technical point of view. So without further ado, let's just start our talk. So let's start with the reasons behind this talk. All right. So all Android developers every day come across the Android context, even in the most basic applications. Yet, because the context can be used under various circumstances for different reasons, it can be hard sometimes to absorb it, resulting in developers forming varying impressions around. The outcome, well, several developers just end up passing a context when necessary through the application or the activity objects without further thinking, since their code will just compile and run anyway. However, poor usage of the context in the application code can lead to memory leaks and to a few nasty crashes in your app. Also, ambiguity about what the context is or why it is used prevents developers from having a clear picture of the actual code they write and the libraries they use. Now, much of the confusion around the context begins by not realizing how closely it is related to the manifest, but also by not knowing that when looking at them together, they can expose much about how applications are coupled with the actual Android system. So as a result, in this talk, we will approach the manifest and the context in respect to the underlying Android architecture, so you can understand what they semantically represent from an application mechanics standpoint. Well, for all that, we will intentionally avoid code technicalities and stick to what the context really represents and the problem is called to solve. Because understanding should precede learning and not the other way around. However, to do so, I will refer to several Android components. Yet you will see that everything will be centralized around the Android context and how it binds with the Android system. So grab a cup of coffee and let's get started. So what happens when you install an Android application? When you install an application, the app is given its own unique Linux user ID, and it runs on its own instance of the Android runtime. Thus, each application is completely isolated with all its resources inaccessible to every other app. Then when an application is run, it is restricted from constructing and managing its own components and accessing even its own resources by direct code. Instead, it depends on requesting the Android system to do all that on its behalf. Now, overall, this isolation approach assures a more secure, better structure, and even less error-prone application due to leaving much of that responsibility to the operating system rather than to developer code. But if the Android is that restrictive to its applications, this raises two issues that need to be addressed. Firstly, the applications need a way to communicate with the Android system so they can request it to construct and provide components and resources that are otherwise inaccessible directly by code. And secondly, the Android system should keep track of all installed applications and their components in order to launch or provide them back to the caller when receiving a request that fits their existence. Now, to address these two problems, the context and the manifest, respectively, come to the rescue. And as you can see, there is an obvious correlation between them. So let's start with the manifest. All Android developers should be aware that every Android app they build is accompanied by the Android manifest XML file. When you create an application, the Android system really knows nothing about it unless posted in the application's manifest file. Even to have the application's icon at the app drawer, you need to declare an activity to be the launching activity via some implicit intent declaration using an intent filter in the manifest. Now, inside the manifest tag of the Android manifest XML, you declare three things. You declare firstly, package information of the application, so the application can be added to the application layer of the software stack by the Android system, so it can become reachable after it's been installed. Then we have permissions, using the permission tag for Android to know what restricted hardware and software resources should be made available to your application once the application user runs. And finally, any custom subclass implementation of the four application components you wrote inside your application for Android to index them so it can provide them back to the caller when an application request fits their existence. Now, these subclasses can be submitted to the manifest through the following tags: activity for activities, service for services, provider for providers, and receiver for broadcast receivers. Now, there is a reason we call these four classes the four application components. That is because out of all the custom classes we create in our code, only subclasses of these four components can make it inside our manifest through the mention tags that we just mentioned in the previous slide. But why does Android need subclasses of specifically these four types to be declared in the manifest? Well, let's start with intents. So, when you make an explicit intent from some activity to operate another activity, you never really create the new activity object and pass variables to its constructor. Instead, what the explicit intent does is ask the Android system to create and launch the target activity on your behalf, and then pass a bundle with data rather than passing constructor parameters. And that's what an explicit intent really is. Now, how do intents relate to the manifest? Well, now because the Android system has already indexed all the components during the app installation, thanks to their associated manifest declarations, it knows where to find the requested component in order to construct and launch it on behalf of the intent's owner. Now, on the other hand, when you make an implicit intent, you don't really know what activity will handle your request. In that case, the Android system will check all the manifest declarations that fit the request's intent filter for every installed application in order to figure out what set of activities or other component types can handle your intention. So it can then launch the appropriate components that serves your intent filter. And now, as a side note, it should now make sense why bundles only can contain a fixed set of data types. It is because in intent, it is the operating system that will construct the components on behalf of the caller. And therefore, the operating system is what should also pass and forward the parameters from the caller to the target component. So bundles is a mechanism to pass compressed parameters between two components with the operating system sitting in between. For Android to pack the caller's data or serialize it and reconstruct it at the target component or deserialize it, it needs to use data types it knows about. So, or combinations of such types, because you can use custom types that contain these types inside them. So that's why we also have fixed data types in our bundle. So it all makes sense. It is just because the Android system will construct our components, and we will give to the Android system the data, which will then forward to the component it will create, because it is the Android system that will create that component and not us. So you can think of intents as intentions, okay? So intents is Android's way to have a context, which we will discuss later, ask the operating system to construct and launch or deliver application components on behalf of the caller app, like starting other activities, services, or delivering broadcasts. So let's take a brief look at each application component and its relationship with the manifest. Okay, so activity is a single focused thing that a user can do. So activities are the application components that host the UI by inflating layouts with some content view. Android is aware of all the activities that can be launched implicitly or explicitly, thanks to the registered activities entries in every manifest out there. Services can perform long-running operations at the background. They do not provide a user interface. Once started, the service might continue running for some time, even after the user switches to another application. So, its connection with the manifest, Android is aware of all the available services through every app's manifest declarations, so it knows what background operations it can launch. Now, content providers manage access to a central repository of data. You can use content providers to provide data within your own app or to provide data to other applications. For example, to access a phone's contacts list, you will need to request a content provider for that list's content to be provided to you. So its relationship with the manifest, Android is aware of all content providers, so it can provide content to your app or other apps when needed, thanks to the manifest declarations. And finally, broadcast receivers are there to receive broadcasts made by some Android service or application. And its relationship with the manifest, Android is aware of every receiver registered to listen to a broadcast, thanks to the receiver's entry in the application's manifest. So when even the app is not running, the receivers that are registered to a specific broadcast will get notified. Now, I should make a side note here. I need to mention that it's not obligatory to declare receivers in the manifest, because apps can receive broadcasts in two ways: by manifest declared receivers using the receiver tag at the manifest, or by dynamically registered receivers at runtime using the context.registerReceiver method, where the receiver can listen to broadcasts for as long as we ask it to listen, and not permanently as it would be if it was declared at the manifest. So the four application components, when declared at the manifest, they let the Android operating system to know that they are there, so it can take action when some request by your app or some other application fits their existence, explicitly or implicitly. So let's sum up the manifest. So the manifest, one, notifies the Android system of the application's own existence, any permissions required, and the components of your app, so Android can launch or access them on your behalf. Now, this approach yields a potentially richer application experience due to other applications' components becoming available to your app through their manifest declarations, either by fitting your implicit intent filter or by providing you their content with content providers. So we have a really rich experience, a potentially rich experience, thanks to the manifest. Now, before talking about the context which follows next, we should make clear that not all manifest entries refer to context class descendants, okay? Now, context manifest entries are context class descendant objects that perform UI or background operations. They are directly constructed and launched by the operating system, and because of that, they have a life cycle whose state is administered by the operating system. These manifest components are application, activity, and service. And if you notice, I said manifest components, not application components, because the application is not one of the four components, but it's a component of the manifest, okay? So you see that the class hierarchy for anything that inherits from the context is in blue color in our graph. Now, on the other hand, for non-context manifest entries, we can say that they are the objects that employ a provided context to get a standardized job done, but they are not context descendant classes themselves. And as such, they do not have a life cycle that is exposed to you via method events, okay? So these manifest components are the broadcast receivers and the content providers. And as you see from the graph, these are highlighted in green, and they do not inherit from the context class. Now, more specifically, for the non-context manifest components, let's look at some notes from the Android developers website, okay? So, for content providers, when you want to access data in a content provider, you use the content resolver object in your application's context to communicate with the provider as a client. So that is, with content providers, we use application context as a communication vehicle to be provided with the desired content. So it is not a context, but we use a context. Let's look at the broadcast receivers. Well, the broadcast receiver class is the base class for the code that receives and handles broadcast intents sent by a context.sendBroadcast with a past intent. And that is from a broadcast that was delivered to the Android system via a context by your app, another app, or some service. The Android will notify all the receivers registered to listen to that broadcast. So here we also see that a context was used for the broadcast receivers even though the receivers are not inheriting from context. So we have, as we have here, let me go back, we have the application, activity, and service, which are contexts because they inherit from context. And we have broadcast receivers and content providers, which employ a context to get the job done, but they are not context themselves. So let me go to the next slide. So, all right, so let's get to the Android context. Now that you got better grasp of the manifest, you realize that with so much burden falling to the Android system, your app needs a handle to the Android itself to pass its requests in order to obtain content. But and that handle comes in the form of an Android context. But before anything, let's look at the official context definition by Google, which by the end of this talk, I hope it will make perfect sense. So we will take this official statement sentence by sentence and see what we can make out of it. So the context is an interface to global information about an application environment, which means that because the context is your application's handle to the Android system, it also opens a window to observing information regarding the device environment your application is running at. Okay, so since we use this to talk with the operating system, then it is also the window to get system information. So that system information could be things like if your device is using dark or light theme, if the device is in a landscape or portrait mode, but also seamless integrations to global setups, like applying the correct font size to a custom text view by combining the device's global font size setting with your custom SP value, so it can come up with the final font size that will be rendered in the text feed during layout inflation, and more. Then, it is the abstract class whose implementation is provided by the Android system. Here are two things to note from this sentence. First, being an abstract class means you will never find any direct context objects, but you will find objects that inherit from context and get access to the context through these objects, such as activities and services, for example, as we saw in a couple of slides before. And secondly, the other thing to note from this sentence is that the implementation of this class is provided by the Android system, which means that if context is implemented and provided by the operating system of running on each different device, then it makes sense that what we said earlier, that the context is the handle to the actual Android system. So you can use the context objects to talk with the operating system. Okay, so since the implementation is provided by the operating system, you can use it to talk with the operating system. Another thing to note from that sentence as well is that also since the implementation it's provided by the Android system, that constructing context objects should happen from the Android construction mechanisms and not from any standard construction mechanism. So it is the Android itself that should construct objects that are provided by it. Okay, so that's why it makes sense to use intents, for example, to create objects that are that inherit from context and not create them directly by developer code. And finally, since the implementation of the context is provided by the Android system, as we said, each object that inherits from the context has a life cycle, because It is the Android that builds that object on your behalf, and it's managing its life cycle because it's not made by you, it's made by the operating system. It's constructed by the operating system, and the operating system knows exactly its life cycle. So it was so many things that we saw here from this sentence. We first saw that the context is an abstract class, so you cannot find it directly. And then we saw why, since it's implemented by Android, you get a context which is your handle to the Android system. It's something that gets a life cycle, and it is something that should be constructed by other mechanisms other than the standard mechanism that you have with the normal constructors. It allows access to application-specific resources and classes. Yes, resources too are provided by the Android system through the context and not by direct application code. Android provides resources by a key value-based mechanism that uses a context to request the resources value. This is not only secure, as you don't get file system access to the REST folder, but it's also smart, as the Android system can even decide between returning different variations of a resource's value based on global settings. For example, based on the device's language preference, Android can return the appropriate value of a string resource kept in multiple language versions. Okay? Another example could be returning the appropriate variation of an image based on the pixel density and the size of your device screen, and so on. So one of the reasons we get resources by the Android system, not directly, it's other than not having access to the file system, which makes it more secure, it is to get the correct variation of that resource if a resource can be kept in multiple variations. And for the final chunk, app calls for application level operations, such as launching activities, broadcasting and receiving intents, etc. So this final part says that the context can also be used actively as the way to make app calls to the Android system to launch or provide components, provide other manifest, to launch or provide components of the manifest. It is the place where the manifest actually and the context meet, with the context requesting actions on components that only the Android system can fulfill by looking up the manifest entries. So it can fetch them or launch them as requested. So the Android context binds your application with the Android system for anything that cannot be done or retrieved without going through the Android system. So where can I find the context? Since the activity, service, and application classes are all context class descendants, you can pass instances of these classes as your actual context in your method calls. But since the above classes have different life cycles, passing, for example, an activities context as the Android handle to something that is related to the entire application, your activity wouldn't ever be allowed to be garbage collected, as you would always hold a reference to it, which is a memory leak. Okay? So why not just always use application context instead, since all we need is a handle to the Android system and forget about memory leaks forever? Okay, why not just pass the application context, which lives as long as the application lives? Well, activity inherits from the context theme wrapper, while the service and the application do not. You see that theme in the word class? So you see that the application context is not UI related. It cannot be used to inflate layouts, start activities, or display dialogues. If you attempt to affect the UI using a context that is not UI related, you will only crash your application. A classic example to that is trying to display a message inside a service. Also, another reason why we use different lifecycle contexts, depending on the context we pass, we get different access to different information about the application's environment. Like with two different UI context objects at the same application that use two different themes. You would get different information about your environment in different themes. And now, for other tasks, like a singleton object, for example, that will be used throughout the application and requests a context like access to database. You will use the application context in such cases to avoid memory leaks, because you will hold the same database reference throughout the application lifetime. So as you see, depending on what we do, we should query different contexts, okay? So whenever you try to do something that needs the Android OS to act as an intermediary in order to fetch global information, resources, perform tasks, or provide content that cannot be handled directly by your code, you will have some method call that requires passing a context. So the role of the context in method calls. Passing a context in method calls in Android is frequent. However, the fact that you may pass a context for completely different reasons is a major source of confusion for developers, as the context role is not clear. And as we saw on the context definition, because the context is a bridge between our app and the Android system, it can serve multiple roles. Okay, so we have the passive role, which is to ask the operating system for some information. For example, what's the value of a resource? Another role could be the active role, to ask the operating system to perform some action on your behalf. For example, launching a component through an intent, inflate some layout, display a message. You will use in the context in such cases. And there is actually a third role in method calls when we use a context, and that is to connect your application to a distant entity managed by the operating system. For example, opening a connection to an SQLite database, where that binding will be used in both active and passive roles to read and update the data in the database. And in such cases, as we also said earlier, you almost always use an application context, as such kind of bindings usually live for as long as your app lives. Now, in any case, the context is always the operating system intermediary that stands between your code and the Android system, delivering requests in order for some information to be retrieved or some action to take place by the operating system. So the next time you use a context in a method call, you will know it is the vehicle that will reach the OS and ask it to execute or retrieve your method's request. Now, on top of the three roles of the context as a method parameter, there is another role that represents the context as an object instance of a custom class that inherits from the context class, or like the activities or services and so on. So a custom activity or service you wrote on your very own application are context descendants. And when constructed and launched by the Android operating system, they obtain a life cycle. As you can see from the diagram of the Android platform architecture, or otherwise the software stack, your application is put inside the application layer together with all its application components. So the component role that represents a custom launchable component. is this. It's these custom launchable components belonging to the application layer of the software stack, but extend or use classes defined in the application framework. And as such, they serve as a bridge, as a wire between the application and the operating system. When these context-descendant components are created and launched by the Android operating system with mechanisms like intents, rather than directly by normal constructors, they are given a life cycle, which is managed by the operating system. For example, for a class that extends the activity class, if you try to instantiate it by normal means, like using myActivity object equals new myActivity, the onCreate method will never be called. Only if you start the activity with an intent will the method be called. Okay? So the role of the context as an object is to bridge its subclass launchable component, like the activity. So it's actually to bridge itself, okay, with the Android system. So the Android system can provide and update the lifecycle status of that component. So there you go, all the roles that the context can have, even lifecycle. So the context summary. The context is an abstract class provided by Android, and as such, its job is to bridge your application code with the Android system. Through classes that inherit from context, your application gains the ability to access resources and functionalities reachable only by the operating system. When objects of such classes get instantiated by the operating system through an OS control instantiation mechanism like intents, they become administered by the operating system, and as such, they obtain life cycle. For anything else, passing a context as a parameter in method calls allows this method to use the context as a channel of communication with the operating system in order to reach the OS and ask it to perform some action or return some resource value. So, to visualize the concept of the Android context and the manifest in action, an old calling center switchboard sounds like a good analogy. The base is the application framework, where all the wires that connect every application component with the Android system emerge from. Then, each application, through its manifest declaration, exposes plug holes for every declared component. So the Android system can then construct them and put a context wire to manage them. And finally, each wire is the Android context, part of the constructed launchable component that binds that application component with the Android system. So the manifest adds the applications to the application layer of the software stack and creates the plug holes for each application and its components. When the Android system constructs a component that inherits from context, a context wire automatically is plugged into the newly constructed component's plug hole, so the OS can link to it and manage it. You can assume that during component destruction, its wire gets unplugged, while when another component gets constructed, a newly wire emerges and connects to the corresponding manifest declared plug hole. So this is how you could visualize all these together. Now you know why the context exists. You will appreciate the difference between local and instrumented tests. Well, in a nutshell, unit tests do not require any interaction with the Android operating system to run test code. They just run on the JVM, okay? While the integration tests assume the involvement of the Android operating system with your code at some point. And thus they need to be run on an emulator or on a real device, making them significantly slower and cumbersome than the local unit tests. So instrumental tests are usually required when you need to perform something that involves heavily the operating system and obviously involves a context. Or if you're testing custom components, which are context classes themselves, like testing an activity, you have to test it in an instrumented test. You cannot test it on the JVM. Now, with all that in mind, as a side effect, for simple cases where you just need a context that doesn't require deep involvement of the operating system, like you want to mock a fixed resource string that you would get, okay? So you don't do something very complex. There are ways to mock it, okay? Which are out of the scope of this talk. But in unit tests, for simple cases, you can, how can I say, you can mock a context during testing. Now, with all this in mind, if with design patterns like the MVVM, which is endorsed by Google, you can keep all the business logic in the view model, right? And keep that logic away from UI-related code and from data layers by providing mock data to the repositories with sample data. So you can separate completely the data and the UI from the business logic. Then your business logic would be clear of any context items. So you can then test your view models with local rather than instrumental tests, leading to faster testing and a much better and easier to debug code. But to isolate the business logic, it's necessary to understand when your code involves the Android operating system and when it doesn't. So understanding how your apps are coupled with the Android system can help you acknowledge even further the reasons behind choosing design patterns like MVVM that promote separation of concerns and maybe even adjust the way you approach code at the first place. So, closing, let's close with the significance of the context. As we saw from the testing section of this talk, if the context didn't exist, every test would run as a unit test. I mean, and thus the Android system would be nothing but libraries built on top of the JVM. Okay, that would be Android. So if the context didn't exist at all, you wouldn't have an Android app. You would have a Java application or a Kotlin application that would simply require a few additional libraries, and it would work at any operating system with a Java runtime environment installed. So with all that, we can argue that it is due to the context, your application is an Android application. So I'm done, and I'm ready for any questions you might have.
So, John, many thanks for the insightful presentation. We really appreciate your time.
Thank you.
As far as I can see, we have a question from Leo, which asks, is there a way to use autocomplete in Android manifest or a way to validate the manifest before actually testing on a device?
Well, for most part, the when you make an application, the manifest is completed by the Android. You have to actually change things on the manifest, mostly for things like like the permissions or some details when you create an application components. Many parts of it are made for you. Others are just, it's the same steps every time that you do. It's not something big. I don't know if I have answered the question or if I didn't understand it very well.
No, I think it was clear. And we have a special request. Actually, someone mentions that make sure to link the video from your Medium article too. So please don't forget it.
Oh, all right, okay. I will do that if you just allow me one
The
second to get
question
my.
is via the YouTube channel.
All right, okay. Just bear with me a second, and I'll get the link. Yes, actually, this talk was. You can find all the content of this talk inside the Medium article I have written, and I will just post it here. Just one second. Um, how do I paste at the chat? How do
You
I
can
put a
simply
comment?
actually visit the YouTube channel and they comment under the comment of Sri Harsha Chilakapati. Sorry if I do not pronounce it very well.
Sriharsha, yeah, okay. And I'm not sure how I cannot reply for some reason. I don't know.
Actually, what is
Okay,
the link at your Medium account so everyone can
okay.
find you?
All right. It's I sent it on the private chat, so you can see it. You can do it for me.
Great. Yeah, sure. Of course I will. That's great. Once again, thanks, John, for the presentation. Many thanks to everyone actually who joined us today. That's all, folks, at least for now. From all of us at the GDG Athens team, we wish you to enjoy your summer vacation. So stay safe and enjoy. See you soon.
Thank you.
Bye bye.
Bye bye.
Technology brings us closer together, even when we're far apart. Google developer groups host Meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching introduction to programming to 7 girls in my hometown.
In the GDG, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members a lot. So I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.